Okay, so another AQA Physics A-level question. This is another current electricity one. Okay, pause the video, read the question if you haven't already. Right, so we're asked to calculate the current through the ammeter when the switch S is open. This is open, okay? Having taught this for several years, I realise some students think of a light switch being open when the bulb is on, but you should look at the actual circuit, and when there is a gap, it's like a gate that is open, and that's the way it's thought of in the physics world. Basically, an open switch is one that is not allowing current to flow through it. So it's in the open position here. Calculate the current. Relatively straightforward. Application of Ohm's law. So you're starting with V equals IR, rearranging for I. Okay. Current flowing through. Voltage is 6. It says negligible internal resistance, so we don't have to worry about internal resistance. You need the total resistance, that's 60 plus 20. Okay, so when this is calculated, we get a value of 0.075 amps. Okay, relatively straightforward. Right, now when the switch is closed, right, so the switch will be in this position now. So now what's going to happen is, and this is what it's testing the understanding of, is that any current flowing through here is going to bypass this, right? Really what's happening is that this is like a parallel component of the circuit. You've got a resistance here and you've got practically zero resistance here. So whatever current flows down here, a portion is going to go this way and a proportion is going to go this way. And it's to do with the ratio of the resistances. And since the resistance of this is practically zero, practically all of the current flows down here. In fact, it's so high that you can treat it as though zero current flows down here. Essentially, you've shorted out the 60 ohm resistance. So now really what we've got is a circuit with 6 volts. So we're going to work out I again. I equals V over R, sorry. We've got 6 volts, but this time the resistance is only 20 ohms. Okay, and when calculated, this gives me a value of 0.3 amps. Okay, so next step. The switch is now replaced with a voltmeter with infinite resistance. Determine the reading on the voltmeter. Just as a side note here, there's no such thing as a voltmeter with infinite resistance. They just have extremely high resistance, but this is in an idealized situation, and it's also, you've got the cells with practically zero internal resistance, so it's an idealized situation. So the idea is now this has been replaced with a voltmeter, and determine the reading on the voltmeter. Right, so what's actually we're saying then is, previously we said this had very low resistance, therefore all the current flows through here, it bypasses this. Well, now this has practically infinite resistance, so it is as though we're back to situation number 1, as though there is a open switch there, because obviously the air has a very high resistance. So we're back to the situation where you've got a current of 0.75 amps flowing, 0.075 amps flowing throughout the circuit, right? That way, that way, that way, it's all the same. In series, the current is the same everywhere. So to work out the voltage across this component, relatively straightforward. V equals IR. I is 0.075, R is 60. 0.075 times 60 gives me a value of 4.5 volts. Okay, so that would be the answer for here, 4.5 volts. So I've got a value of 4.5 volts across this component, and since we're kind of trying to develop our understanding here as well, let's just check out, does that look reasonable? Is it correct? So Kirchhoff's law has to apply in the situation, right? So whatever voltage law has to apply. So this 6 volts is shared out, right? So that's the voltage across the entire circuit, so it must be the same as the sum of the voltage across all the components in the circuit in series. So I'm guessing that this should be equal to 1.5, right? Because 4.5, 1.5 add up to 6. But we can check it. So if I calculate the current through this component here using I equals V over R, I should get the same value again of 0.075. So I equals V over R. V I'm saying is 1.5, and R is 20. And just check that on my calculator now, and I'm pretty sure it's going to come out as 0.075, but my mental maths is just not up to it at this time in the morning. 1.5 divided by 20, 0.075. Excellent. Okay. And again, you can also see the ratios there as well. You've got a 60-20 ratio, 60 to 20, and you've got a 4.5 to 1.5. And if you calculate this comes out as 3, and this also comes out as 3. So you can confirm it several different ways. Potential dividers, they come up a lot. Alright, I hope you found this useful. Thanks for watching. Please comment, like, subscribe, share, etc.